Hey there, curious minds. Welcome to Let's Science with Dr. Jeks, your go-to spot for IGCSE revision made simple, smart, and super engaging. Whether it's math, science, or anything in between, I've got you covered with clear explanations, exam tips, and everything you need to boost those grades. If you find this helpful, don't forget to like, subscribe, drop a comment, and share with your study buddies. Let's learn smart, and let's start.
Sine and cosine of obtuse angles, explained simply. Okay, so up until now, you've only been using sine and cosine in right-angled triangles, right? But did you know that your calculator can actually give you the sine and cosine of obtuse angles as well? Try this out on your calculator just to check. The sine of 115 degrees is 0.906. The cosine of 115 degrees is negative 0.423. Now here's a little puzzle. You can't have a right-angled triangle that contains an obtuse angle, because an obtuse angle is any angle greater than 90 degrees. So then, how on earth can we find the sine and cosine of an obtuse angle? Let's visualize it, rotating a rod on the unit circle. Picture this. You've got a rod named OP lying flat along the x-axis. Let's just call it the r-axis for now. The rod is fixed at one end at the origin, which we'll call point O. Now imagine rotating this rod in an anti-clockwise direction around the origin. As it rotates, it traces out a triangle ONP, and that triangle is a right-angled triangle. Let's also assume that the rod, OP, has a length of exactly 1. That's why we call it the unit circle, because the radius is 1 unit long. What happens when the angle is acute, between 0 and 90 degrees? So let's say the rod OP makes an angle called theta with the x-axis, and theta is an acute angle, meaning it's between 0 and 90 degrees. Here's what happens. The length of the adjacent side, that's on, is equal to 1 times the cosine of theta, which is just cosine of theta. So the x-coordinate of point P is cosine of theta. The length of the opposite side, that's NP, is 1 times the sine of theta, so just sine of theta. That means the y-coordinate of point P is sine of theta. So basically, when theta is acute, the coordinates of point P are cosine theta, sine of theta. Now, let's see what happens when the angle becomes obtuse, between 90 and 180 degrees. Alright, now let's imagine that the rod OP keeps rotating. Eventually, theta becomes an obtuse angle, meaning it's greater than 90 degrees but less than 180. Guess what? You can still find the sine and cosine of that angle, and it still relates to the coordinates of point P. Here's what you'll notice from the diagram. The x-coordinate of point P, which is cosine of theta, is now negative. The y-coordinate of point P, which is sine of theta, is still positive. Let's do an example. When theta equals 115 degrees, say your angle theta is 115 degrees. That's an obtuse angle, so your triangle is no longer in the first quadrant of the coordinate plane. It's now in the second quadrant. But here's the cool part. The angle between the rod and the x-axis is actually 180 degrees minus theta, which gives you 65 degrees. This angle, the 65 degrees, is what we call the reference angle. It's the acute angle that your obtuse angle makes with the x-axis. Let's wrap up with a final calculation. If theta is 115 degrees, then 180 degrees minus 115 degrees gives you 65 degrees. So, the sine of 115 degrees is the same as the sine of 65 degrees, which is 0.906. The cosine of 115 degrees is the negative of the cosine of 65 degrees, which is negative 0.423. So what's the big rule here? Here's the golden rule you want to remember when theta is obtuse. That is, when it's between 90 degrees and 180 degrees. The sine of theta is equal to the sine of 180 degrees minus theta. In other words, same sin value. The cosine of theta is the negative of the cosine of 180 degrees minus theta, so the cosine becomes negative. And that's how you can figure out the sine and cosine of obtuse angles using just a little geometry, a unit circle, and some clever thinking. Thanks for watching. If you haven't done so already, don't forget to like, subscribe, and drop a comment if you've got questions. Click this video right here to dive deeper into the topic. Keep learning, and let's science.